Synthetic division as a strategy offers us an alternative to polynomial long division, but only in very specific cases. Here I have a finished example of polynomial long division. We have the polynomial x cubed plus 4x squared minus 5x plus 5 divided by the binomial x minus 3. You could certainly pause the video and go through the steps to ensure that this is the correct order and signage of all of the parts of the long division. I thought it would be interesting to take a look at how this compares to what synthetic division will look like without actually going through all of the steps of the synthetic division to start. So looking at this polynomial long division and comparing it to the synthetic division, which we see here, you're going to notice a lot of the same characteristics, and a lot of the same numbers are going to pop up in what seem like important places. For example, you'll see that our very last number down here, our remainder, pops up as the very last number in the bottom right-hand corner of the synthetic division. And you'll notice that there's a relationship in each one of the columns, similar to what we have over here. Here we subtracted to create each number in the column. Here we're going to add. And we see this number 3 on the outside and having that same outside position in the synthetic division. So all of the same characteristics from long division and all of the same numbers and all of the same valuable information is going to be available to us when we do synthetic division, but in an obviously much shorter way. This is a much more efficient process. But synthetic division's downfall is that it only works in certain situations. So let's see what those situations look like. Synthetic division as a setup only works if your binomial divisor has a coefficient of 1 in the front and a constant term being added or subtracted. You'll want to be careful when you set up the synthetic division. Synthetic division is originally designed for this to have a subtraction symbol in it. If it has an addition symbol, that's okay. You just have to use a negative number when you set up the division. And we'll see an example of that in the next video. So how is synthetic division set up as a strategy? Well, since we know that the divisor is going to be a binomial with a coefficient of 1 followed by a constant, we don't need to write all of that. They shorten all of that work. So on the outside of the synthetic division, we just put that number that's being subtracted. And again, if that's an addition, we'll have to switch it to a negative, which, like I said, we'll see in another video. So on the outside, we're going to put that 3. And we follow that 3 with all of the coefficients from the dividend. So we have a 1, a 4, a -5, and a 5. So we're going to follow each one straight in line. Same rules apply for synthetic division that applied to polynomial division. If there's a term missing, you'll want to use a spacer term. And if they're not in order, you'll want to put them in order. You want that polynomial dividend to be in standard form. Now, the work of synthetic division is actually not too difficult. It's a lot of multiplications and additions. So synthetic division goes like this. We bring down this first coefficient. Think of this as the first division. That's x into x cubed. So what coefficient is that going to create? It's going to create a coefficient of 1. The number that goes right here underneath the 4 is created by multiplying the 3 and the 1. So we go diagonal next, and we do 3 times 1, which is 3. We add down and create 7. So then we go this way, and then we'll go diagonal again. 3 times 7 is 21. Add down again and get 16. 3 times 16 is 48. 5 plus 48 is 53, adding down. And that's our finished version of our synthetic division, the exact same answers that we got here. And we'll revisit this in just a moment. When we write our quotient for the synthetic long division, this answer polynomial, this quotient polynomial, is 1 degree less in each of its terms than the original dividend. So if the original dividend went x cubed, x squared, x, and then the constant term, we're going to do the same thing here. We're just going to drop the term down. We're going to say this is going to be the x squared term, this is going to be the x term, this is going to be the constant term, and as was suggested on the previous slide, here's our remainder. So synthetic division will pop out a result for us of x squared plus 7x plus 16 plus the remainder of 53 over x minus 3. Now that you've seen how synthetic division works, let's go back. All of these numbers that are over here all appear in some way, shape, or form in the original long division. All synthetic division does is it proves to shorten that work just a little bit, make it a little bit more of an efficient process. Here's our coefficients of the dividends. Here are the numbers that come out of the resulting multiplications. There's the 3, there's the 21, and there's the 48. And then here are the coefficients of our results, understanding that the remainder is the final term that we see.